All right. Good evening, everyone. Once again, my name is Olorunfemi Davis. Um, yeah.
Yeah, Olakunle Abiola.
All right. Special thanks to Kevin, the organizers for .NET Sheffield, .NET York. It's my first time in York, and I think it's more beautiful than Sheffield. And yeah, I think it's far more beautiful than Sheffield. So it's good to be here today. Um, So today we'll be talking about a cultural story. Um, yeah, during my first event at .NET Sheffield, I, 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 I listened as an audience to a very interesting talk about birds and how it can influence somebody, like developers, engineers, different kind of people, and how you connect with nature. Then the speaker was able to relate how trying to interact with his bird helped his life. So tonight we're going to talk about our background, our culture, the experience here in York. I know here is in the north side. Then we're talking about how we have a demo app, which is a cultural storybot that can combine local data and information, then bring that up into a kind of a dialogue screen where you can interact with it. Then we're talking about the technical stacks and architecture. We'll be talking about, we'll also be having a QA if our times permit. Okay, thank you. So this is how I see everything here is AI generated, but this is how Sheffield looks. A lot of greeneries, a lot of plains and hills and mountains, and of course the urban buildings and layers. And this is how Lagos looks like as well. You have the interesting mix of urbanization and also the street style of, you can see, I think that's a market area right about the road, so you can imagine it's somewhere down there along the train station filled with thousands of umbrellas, people buying and selling. That's the kind of lifestyle there in Lagos. And of course, moving to Sheffield was a quite remarkable experience for me, for my family, and I've gotten to see a lot of people also from my country living in Sheffield and in different fields and sectors on engineering, manufacturing, finances, and other things like that. So when I was in Lagos, I enjoyed going to the beach a lot. With my family, that's my son there. Where I enjoyed. Lagos is a coastal region, so there's a lot of Atlantic Ocean around. So I enjoyed going to the beach and seeing the lifestyle here. Here is I've joined a working group, and we went around the Bent Hills here, trying to explore the natures, also exploring the very beautiful scenery there. So he's going to talk about his own experience.
Yes, so hi everyone. So I would also say moving from Lagos to Sheffield was also kind of a life-changing experience for me. Yeah, so I moved to study and I experienced a lot of cultural differences, more of positive. So I'll say one of the things that I noticed first was when you're walking through a door and you open the door, or someone ahead of you would hold the door for you, which really doesn't happen where I come from. So I had to learn to also do that, for other people. And some differences in what some phrases mean also was a culture shock for me. Like here, a lot of the greetings is, okay, people greet each other by saying, "Are you all right? Are you all right?" Which in Nigeria If you say that to someone, the person may likely punch you in the face because it's almost like you're asking the person if they are mentally fit. Yeah, that's the difference. Yeah. So now I've learned to say, "Are you all right?" always. Okay, so yeah, since I've enjoyed coming to the UK, I've enjoyed seeing the Premier League, even though Sheffield United did not go to the Premier League this season, so I won't be able to see some of the games. I've enjoyed playing football and also, going around Sheffield on walks. There are a lot of steep, um, um, like grounds to climb on, and my calves are getting stronger here. So because I think I also noticed that people in Sheffield are kind of healthy, although a lecturer of mine argued that yes, it's because of most of the climbing and the hills here. So they get a lot of exercise. So next.
Okay.
Yes.
So today we'll be comparing what we've observed about Yorkshire and Lagos, Nigeria. So we're talking about tea, music, transitions, dialects, food, might, and dance. Some of these might be ancient and they might not be common today, but these are just what we've found out. So in comparison with the tea, we used to have a drink, Zobo.
Yes.
It's made of hibiscus flower, and some species have some purple color to it,
Yeah.
natural flavor. Very, very sweet. You're going to enjoy it. Then the music, I've always listened to Celtic music from back home. I enjoyed some of this Celtic music when I was a bit younger. And of course, in Lagos, we have the Afrobeat, topped by artists like Burna Boy, Davido, some of the artists that you might have heard of. Then I learned about the Wasaling Vikings festivals, which sometimes is about wishing for a bountiful harvest for apple trees, if that is correct. And of course, in Lagos, we have the Eyo Festival, celebration of whiteness and uniqueness, and the collaboration in honor of the legendary Afrobeat star Fela Kuti. Then,
I think you should go for it.
help, and can someone help to pronounce this?
No.
Nout. It means nothing. It's nothing. Like, it's nothing. Around it. So then back home we have something called alpha and IDH. So alpha, what is alpha and IDH?
Yeah, how far is almost like saying, "How are you?" I've had a funny experience where a friend asked, "You guys always say how far, how far. Is it like you are trying to measure distance?" So I had to correct him, no, that it's just a way of asking someone, "How are you?"
Yeah.
So it's different.
Then there's IDH also, which means I'm hungry. I'm starving. It's more than I'm starving. I'm IDH. Then I've seen the pudding and the Sunday roast, which has become almost a favorite. And of course, we have the Nigerian jollof rice, with competition with the Ghanaian jollof rice as well, and akara, which is made from beans flour. Then in the might, I heard of this bagrest, if I call it right, some dog-like beast that makes people fear. And back home we have mami water. Because of the oceans and the waters around, people see mermaids or objects that looks like mermaid in the water, and then it's part of the myth. Somebody saw a mermaid 40 years ago, 50 years ago, 100 years ago. And of course, the dancing. We have Bata, Zanku, Legwog, and Shoki. And of course, I learned about the Morris dancing. So some of the African dance is quite dramatic and fast, unlike the Western dance that is more rhythm and the movements and the tango, the French dancing, where it
Ballet.
takes to ballet and the rest. As I just individualistic and sometimes in sync with other people in the group. So we're going now further into the main topic here, which is culture. Historically, the Western people, I'm giving this to Yorkshire now, they love to read. They love to write. They love to share information in books. Scientists write books, journals. They're always documenting, and this has become the bedrock of science and the various advancements or discoveries in science and engineering and biology. Back home, it's more about folk people sitting down and around older people and trying to hear verbally from them stories of the stars, of space, of science, of medicine, tales, different kind of stuff. And because most of the knowledge of Africans, they are not well documented, then it leads to some problem that we are going to discover as we proceed ahead. Today, talk about it.
Okay, so yeah, as my partner said, I think the documentation is what has that the West has done is what has helped the development of AI, because with the large amount of data that we have, we're able to train machines to, reason almost like the same way human beings reason. So AI models basically learn from data. For example, the convolutional neural networks, they learn from data and they are able to handle a lot of specialized tasks like computer vision that would have been otherwise, difficult using the traditional programming. Okay, next. And so we have also gotten to the stage where after training AI, giving data to AI is now rewarding us, We are now the ones prompting AI for the knowledge, that AI has been able to learn. So you can sort of see how it's almost like it's the reverse now, because at some point, in the development of AI, the engineers were transferring data into it, and now AI is now able to make what's it called, knowledge, something that is easily available to everyone. For example, a lot of people use the popular OpenAI product ChatGPT, for a lot of tasks. Yes, so a lot of people now over-rely on it.
Yeah, AI is changing basically the ways that people operate. Before people will consult books or libraries or Wikipedias or encyclopedias to get information, but now people can easily ask tough questions, logic, browse around the edge of the laws of physics, trying to get some reason. Hey, is this possible? Can you have a perpetual machine? So now AI is now the powerhouse in terms of knowledge, and this is going to lead to a grand what I'm going to talk about now. So I believe everyone can identify who this man is. I have two questions there: the easy one and the hard one. The easy one is, who is this? Einstein. All right.
Yeah,
Albert Einstein. The second word is the meaning of this word, stability. So, one of our professors, a Nobel laureate, he managed to add a word into the English dictionary, and that is the word fidgety. Yeah, that's the to work like an older man working with stick, right? So this is a word that we will most likely make an entry into the dictionary. But the meaning of this, can you tell us the meaning of this?
Should I?
Yeah.
Okay.
Who can guess the meaning of this stability? Has anyone said this? Stability. Sabi. All right. It means the ability to know. Sabi. The ability to know. It's more like having an intense ability to know, or an intense drive to know, and the drive is met by the ability to receive that knowledge. And that is where AI is getting us to. But The anagram for this sabi, ability to know, is bias. And this is part of the reasons we are making this presentation. Bias, everybody know what a bias is. Bias is when something knows too much of about some things and too little of some things, then it starts to make wrong judgment against a person or a people or a subject or a topic. It doesn't have an equilibrium point of view to express its opinion. Then you say that kind of system is biased. And there's a big problem with AI. There's so much data that AI can derive from the West, because the West has been busy documenting for over 50, 60, 70 years since the computers, microchips were invented. So sometimes when we try to get information about history, for example, history, culture, artifact, what happened 100 years ago, there's a lot of bias seen in that data that AI present. I think last week, Groot was shut down based on some bias that it produced. It was shut down by Hex. So that's why we're talking about the StoryBot here today. So the ability of the StoryBot, we have built it such that it can tell genuine and optimal cultural story and express its views about two different cultures, the culture back in Lagos and the culture we have observed here in Sheffield, based on open data from Lagos and also from Sheffield. So basically, it's a virtual assistant if it is built in a full application form. Long live Cortana. Then, how many of us use Cortana? Or how many of us enjoyed Cortana? I think it died so prematurely. Should have waited. All right, so basically it connects cultures using conversational AI data. And of course, it can answer 4 functional queries. Some information you can discover can be very, very fun. And then it leverages real Nigerian and Sheffield data. So, over to Olakunle.
Okay,
discuss the architecture.
Yeah, I'm going to discuss the architecture of the application we've built. So, because we are using a large language model to produce the story, because it has been pre-trained, it needs external data in order to, be able to avoid that bias. Although I'll say the data we use may not be enough to properly shift that bias. But yeah, the part that is going to help us get the external data is the scraper. It's going to scrape the web. That's its function. So we are using a blog back in Nigeria to scrape the data on the blog to see how people are having conversations about Nigeria, Lagos specifically. Then we are storing it in a MongoDB database. Then the next component is the MCP, which is the new buzzword that most people are talking about in AI now. So what MCP is helping us to do is to sort of simplify the integration. And we also have Copilot, which is another component. So what Copilot is doing for us is helping us to generate generate data that, could be, instead of hard coding data into the code, you could use Copilot, which is also a large language model that is good at programming problems or software engineering problems. Then Semantic Kernel. Semantic Kernel is a framework or a library built by Microsoft to help .NET developers or the .NET ecosystem to easily integrate artificial intelligence solutions into the applications, because most of the AI solutions are written in Python. So it's easy for .NET developers or people in the .NET ecosystem to have something that is closer to them that can help them integrate into the AI solutions that are out there. So it just makes the integration easier and also orchestrates different AI components. Yeah. Then we have the user interface, that is what is going to face the user. So if the user types in a prompt, it goes into the system and the user receives a story back. Okay.
Okay, so I'm going to talk about the scraping process. Sometimes it's just easy to connect directly to data source like API, XML, JSON source, but sometimes you just have to scrape. So the way we position the screen, because we needed terabytes, hundreds of gigabytes or gigabytes of data, we had to adopt the microservice architecture where each microservice focus on just a particular set of instructions. For example, we have a microservice that focus on just fetching the data, scraping the data from the source, while another one is involved for parsing it and sorting it, while the another one is also responsible for deriving intent, deriving information from that data. Then and everything still goes back to the Mongo database. So we considered a lot of choices when we're trying to build a scrapping tool. We have the best proficiency in C# with some C++ experience as well. And this is a bit of a comparison of C++, C# and Go when it comes to scraping. And the winner is obviously Go. It's one of the tools I'm interested in exploring this year. But we were able to create benchmark between when you scrape with C++ and when you scrape with C#, and also when you embed, for example, a C++ library right inside the C# using interoping, and we compared those benchmarks, and we saw that wow, C# is actually very efficient in doing this, and of course it's compatible with the rest of our code. So these are just some of the comparisons that we made up using IGDC Park Jumbo, and the performance is quite excellent here. So we could leverage the speed that C++ gives, and also Go on the other side is also fine, but we could bring this right into our C# program and also host it. Like Kevin said, you can now have your C# code on Linux, on Windows, on Mac. It's still Linux somehow. Yeah, you can have your .NET app running anywhere you want it now today. So that's made it possible by the unified .NET ecosystem. Yeah, so I'm going to go next. Why Mongo database? So because we are dealing with unstructured data at the initial part of the scraping, Mongo database looks like the perfect place to dump those data. And of course, while we are trying to process, so it has unstructured data storage, and while we're trying to process those data as well, we have the ability of modeling the data to our C# models, and that also works quite fast with Mongo database. And of course, support for structure on demand. So when you need to keep rules and demands on the limits when doing data retrieval and validation, MongoDB also provides that efficiency and that purpose. And of course, the last point there is monitoring. So I've used Workbench and different kind of monitoring tools. The MongoDB Compass and the Atlas makes an efficient ecosystem in monitoring the performance of your threads, your networks, and the performance of your data, and of course, real-time insight on the numbers of documents in the tables there. I think that's why we chose MongoDB for this. All right, so back to Olakunle.
Okay. So the core technologies that we used for this application, the first one is MCP, which is the Model Context Protocol. I would say it's just a way for artificial intelligence model to easily do stuffs outside of just pushing out text or receiving text and giving back responses. So because we are doing this integration in .NET, we needed a library that could help us easily do it instead of writing our own sort of implementation of some OpenAI, of some artificial intelligence providers. For example, we're able to connect with OpenAI's ChatGPT using Semantic Kernel easily. We did not have to bother about writing our own wrapper or writing our own HTTP request to call. We just imported the library and we initialized the object, and we're able to, bootstrap the whole thing together. Okay.
Yeah, talk about Docker.
Oh yeah.
Docker.
You want to talk about
No,
yeah.
Okay, so going back to the scraping services, we because we had a lot of data to scrape, it makes sense to take that rather than running it on a single instance or multiple instances. It makes perfect sense to take that into Docker and then be able to create multiple instances. So if there are 10,000 jobs to do, multiple instances of the final data scraping service could run and make that even more efficient over time, while also respecting the limit in terms of the rate limiting of the data provider. Then the architecture.
Okay.
We should be talking about the architecture.
Yeah, okay.
Yeah.
So the MCP architecture is such that you have the MCP clients, which are like a window into what the MCP, what's it called? The MCP server. Okay, let me explain it this way. You have the client on one side and you have the servers on the other side. So the clients talk to the server, then the server talk to other sort of stuff that you'd have integrated with. I wouldn't want to go into much detail about it, but we'll see it in action in the demo, how you'll be able to integrate AI with probably something on GitHub, Cloudflare, or Slack, even a database provider like MongoDB. You could have an MCP server that will help you to connect your AI applications to them, basically.
Okay.
Yes.
So for our approach, we use MCP twice. I do not have the diagram to show it here.
Yeah.
We use MCP while, let me go back to here. Yeah. So we use MCP to communicate directly with GitHub Copilot. So a developer armed with GitHub Copilot can use the MCP server to connect to the database and get custom prompt based on the data that's been exposed on the MCP client. So the MCP client is also connected to the semantic kernel in powering connection to the, for example, tools like Azure Search that connects you to even bigger large language models. Then it takes in consideration your own data in bringing the best result for you. So you can ask things like, give me a JSON form or tell a story as a cultural story bot wants. Then we compared what is also the industry standard in terms of what is available for this kind of integrations. So we're talking about MCP, semantic kernel, and RAG, which is reactive augmented generation. So MCP is a kind of a protocol, as the name suggests, and semantic kernel is an SDK built by Microsoft, and they are pushing it for the .NET developers to enjoy the integrations with different AI services. And of course, RAG is a pattern that is also gaining wide usage and adoption. Yeah. So the purpose. So in designing the great AI tool or in designing an optimal AI tool, many businesses are considering what part of our business can we automate? What kind of business can we bring in here? I once knew a firm that hired an AI engineer, but they didn't know what they could do. They just needed an AI engineer, and then when they got in, then it told, okay, I can use AI to do this and do this and do that. So the purpose for the MCP is for creating better context. When you asking, for example, you want to create a cultural story, you want to give a context. Okay, how does these people see the rest of the world? How does, for example, Africa sees the rest of the world? It gives you that context, the pure information, the pure data. And of course, semantic kernel is for large language model orchestration where you can direct and juggle up and connect to different ones. Then the RAG also is an enhanced answering. The RAG is the most enhanced kind of way that you can bring in your own data with AI to bring in the best result actually. Then you have the usage. So MCP usually used in IDEs. You can to enhance your code. You want to generate seed data. You want to generate a landing page, but based on complaint data, internal complaint data. You could use MCPs to easily bring that into your IDE, or you want to generate some coding team based on internal data that you have. You can easily use MCP to achieve that. Then for the semantic kernel, usually for more conversational stuff like bots, we have the Microsoft Bot SDK. Different bot SDK are available for websites. You want to have an automated support agent that can talk to your customers 24/7. The semantic kernel helps bridge that gap of integration and connectivity. And of course, for RAG, it has to do with bigger search-based LLMs. Then for the audience, so you will discover that platform engineers, software engineers will use more of MCP to improve their work. Front-end people, back-end people that are doing research, while on the work, they'll be using that. While semantic kernels for app developers, people that build support tools, CRMs, they're going to make use of a lot of semantic kernel. Then, of course, AI engineers for RAG. While we are trying to build this, we also try to maintain an optimal flow. We improve the APIs a lot. So we exposed the semantic kernel via REST. Yeah, we exposed the semantic kernel via REST. So we had to optimize it for efficiency. We didn't deploy it to Azure yet. So, but Azure provides a very safe space for .NET apps and others for fast deployment because of the ecosystem advantage that Microsoft has created. Then, of course, we had to deal with performance while passing the data. Passing of data can be very, very tricky, especially when you have a lot of data to ingest in. So we had to handle performance critical data processing by enabling each service to be we separated the concerns. So there's microservice for fetching the raw data for processing. So we could individually scale any of those microservices because there's enough data, enough work to do. And of course, we're able to bring in C++ embedded into C# for interoperability, for speed as well, to harness the speed for C++. Then Docker. You want to talk about it? So we go to the end.
Okay, so yeah, so in order for what's it called, the different components of the system to easily communicate with each other, so you don't have a situation where you are deploying to one environment and it's not working. We had to use Docker, to sort of bring everything together. And we use Docker Compose so that we could just kind of spin up the whole system at once. And yeah, I think that's okay, next. Okay. So the key takeaways that we have here is that we're able to build like an agent to use MCP and for the infrastructure to take advantage of Docker, to also optimize, the parsing of the what's it called, the data that was scraped, using something like C++, which is very good for high performance task. Yeah, and by doing this, our goal was to help developers think of a way of providing context to artificial intelligence model. The context would be the cultural context that we've based this talk on, or it could just be the context of what is going on in your code or what is going on in the domain or in the business you are working for, basically. Okay, so I think demo.
Yeah,
okay.
Demo.
So
nice time
the
for our
parts
demo.
we've been waiting for. I hope nothing breaks.
Hopefully not.
Yeah. Okay. Okay.
It's fine.
Okay.
Okay, so
This side is the. Is it this way? Okay.
so you can just speak.
Okay. Is it duplicate?
Don't waste time.
Okay. Yeah, that's better. Okay, so I think, is there a way to change this to, I don't know if we can see, let me see, view, zoom in. Let me zoom in a bit, okay. Yep. So this is Cloud Desktop. So it's the client that Cloud, built by Anthropic, built for their users to interact with their model. So you also have the web version. The reason why we are using the desktop version is so that we'll be able to use this client to talk to our MCP server. And okay. So I'll copy these prompts and I'll open a new chat and put this prompt here. So just take notes. I wanted to write a story, and as you would have guessed, this prompt would tell it to connect to the MCP server. But I'll just go to the Docker desktop to show you some parts of the application that we talked about. So we have a MongoDB server running here, Okay, I don't know where the Redis came from. Probably from something else. Yeah. Then we have some services, the post-thread, post service, and the general category services. This set of services, their job is to go and scrape data from the web, specifically a blog back in Nigeria, and store that data in the MongoDB database. And then we have our semantic kernel service, which does the orchestration. I'll be showing some codes, but I just want to give like a high level explanation of what's going on. Then we have this DB API service that just helps us to look at what has been stored in the database. And the MCP story server. So you'll notice that we have, we have an MCP story server here. That's the MCP server that the cloud desktop, which I just showed you, will be talking to directly. So let me just run the demo. I would delete.
You want to scrap?
Yeah, I want to. Okay, let me see. No, not delete. Restart so that everything comes up again.
Okay, you want to redeploy?
No, not deploy. Like to restart it so that everything is live. Yes. Okay. So I'm going to shoot this prompt and hope nothing breaks. So sorry. I think it's okay. It's okay. Okay, let's see if it worked. Yes. So we can see that a story was generated on your right side of the screen, and you can see what the model or what the system is doing here. This desktop client sent a JSON. After telling it to generate a story, it sent a prompt to the MCP server, which is this part. And this is different from the natural language that most people are used to, except for us as programmers. So, but you see that the model, first of all, or the client here, turned it into a request that the MCP server can easily. Okay, I don't know why this is. So it turned it into this JSON, which it sends to the MCP server. The MCP server is able to understand this. Then it sends a request to our semantic kernel service, which is the part that glues everything together. And the semantic kernel service also has to talk to the database through another MCP. So I'm sorry we don't have the architectural diagram here, but the stack is you have the client, which is the interface I just showed you here. Then it calls a first MCP that is able to communicate with the semantic kernel layer. Then the semantic kernel layer talks to another MCP that knows how to read data from the database, and it brings this data out, adds some cultural contexts and some other business logic into it. Then returns this data back to the client, which came back in this. It's more or less like you are calling an API with your what was it called? Your client, your AI client. Instead of it just returning text to you, it is able to communicate with, for example, an API.
It's like it's not on.
Which one?
Stuff. You see the response on the screen.
Okay, let me see. Okay, let's see. Okay. Yeah, let me see. I think something has broken, but we sort of get the idea of what it is trying to do. But let me see if I can get an old chart that I did. Yes. Not this. Yeah, okay.
Okay.
Okay, yes. So this is where I got the prompt from. So this was the request that was sent to the MCP server. And then, let me see. So it was checking for progress here until, let me see. Yeah, it was still checking for the progress of the story generated up to, yes, success. And it came back with a story. You can see here it was successful, and it came back with a story. So what this story contains is like a story generated with an AI model, but with context of data that was scraped to a database, basically. So it's not just telling something that is vague. We are forcing it to use data gotten from like a particular context. So for you, that could be something in your business, maybe documents in your business that you want your AI application that you are building to be aware of. It could also be that you want your AI model to be aware of maybe data in your database or your code or any form of data source, basically. And yeah, okay. Is there any other part of data model?
No.
Okay.
Applications.
Okay.
Logs, stuff.
Yeah. So let me see. I would like to show you some aspects of the application, some code to just show you what is going on. So you have this semantic kernel class, and when we are initializing it, we are bringing in semantic kernel. Oh yeah, okay.
This time.
Yeah, I can zoom it. Yeah.
Oh.
So we needed OpenAI we needed the application to connect to OpenAI, ChatGPT, and you can see after initializing semantic kernel here, then using the builder pattern, we added a plugin, which is the OpenAI plugin, to that kernel, and we built the kernel. Then We also used this part to tell Semantic Kernel that it should be aware of our MCP server, basically. And then the rest of the code is different ways of generating stories. So you can generate simple story or stories with some other kind of parameters. So you see this one takes in an object which you could pass in the parameters of the stories you want to the type of stories you want to generate, or you could just pass in just pure text to generate a kind of simple story. And we also have one that streams the data so that you don't have to wait for the data. We have a part that also validates the story. But to summarize this all, what we've done is we've used a client provided by, which is a ready-made interface provided by cloud, to talk to an MCP server. That MCP server now connects to a semantic kernel layer. And you know what we've emphasized on semantic kernel layer is that the semantic kernel is a way for us to glue different AI, providers together. So you saw how we were able to bring in OpenAI into the business logic of the application. And also we're able to use that layer to also talk to another MCP server down the pipeline. Then that final MCP server is able to talk to the database, retrieve information into the semantic kernel layer, and everything goes back up like that. I'm sorry we don't have the architectural diagram, but I hope you understand.
Yeah.
Yeah.
Are you sure?
Yes.
Okay. So one of the great uses that this can help is analyzing logs. So in my experience, sometimes they just dump logs into database somewhere. And of course, as engineers, you want to care about what are in those logs. You want to build some meaning to it. You want to build some context to it. So that's the end of our talk. We hope you enjoyed it. And if you have any question before the time, now is the best time to ask. And if it's too hard, we're going to call Kevin to answer. But please, if there's any question.
Should we do that story? That story, the one after the.
Yeah.
Boys.
Kevin, how long?
Yeah, QA.
Fine. QA.
No, you can share some master.
Okay.
Is it still here?
Yeah.
Okay.
Yep.
Okay. Yes. So, still in the spirit of stories, so we tried to also see if we can break down the concept of MCP, because it's a new, what's it called? The new concept, and I had to watch, I think, about 5 videos to kind of understand eventually what the concept was all about. Oh yeah, okay. So we are going to tell the story of MCP with the story of a kingdom. This kingdom had a king, and he was very wise, and also he was never satisfied. He was very greedy and always seeking for better solutions. And he had a very big kingdom that he had to take care of. And in also this same kingdom, you had wise men, scholars, inventors, different types of people with different background knowledge. So the king realized that there is so much knowledge in a particular vault or vast chamber, where you had some ancient scrolls of information that has been stored in these vaults. And the question, or what the king had to say, is that there's so much knowledge here that he can't read it all alone. And he needs a way to use this knowledge to win some wars. He wanted to go to war, but he needed knowledge from this vault, but it was too difficult for him to read everything. So what did he do? He went and consulted the wise men. He said to them, why don't you guys, build me a machine that can study these vaults and tell me how to win wars? So the challenge for the wise men was to study the scroll, learn from past encounters, and generate strategies that they will use for winning those wars. And that was how the war machine was born. And after the war machine was born, it was able to read through the scroll, generate strategies for the king, and the king was happy and he got a lot of victories, and he felt like he had tamed the future, basically. And yeah, the war machine worked. But something happened again. At some point, the same machine that was built started having some unexpected failures. The machine misjudged some situations in planning the war strategies. It did not really get some strategies right, and so the king demanded answers. And what he said is, it seems only the past, or it sees only the past. It does not know what is happening on the battlefield today. And when you are going to war, if you rely on past data, the battlefield changes and you can lose wars if you are not up to date with what is going on in the battlefield. So the next phase is looking beyond the castle. So the king said, can the machine not, he was saying it to the wise men, can the machine not look beyond the vault? Can it not send spies, gather fresh reports, and use it to adjust its strategy? So the king was asking for something that could basically see what is happening currently, and also, if possible, perform actions based on what it sees. So the solution that the wise men came up with is that they will give eyes to the machine to see the present world. So, and then they invented the magic lens that could see what was going on in the battlefield, which was progress for them. So they could get updates about the enemy's movement, their new alliances, the weather. So all this information could help them win the war. And the new strategy contained ancient wisdom plus the present reality. And it gave them better decisions or sharper decisions to make. And so the result of it was that the king began to win wars again, and the strategies were more precise, and the kingdom prospered, combining, the past knowledge with current intelligence. And I think for us, we are beginning to see some kind of similarity with something we have today. To the next slide. And so the king's ambition still grew again. I thought it ended. So he said, this is all well and good, but what if this machine could act on its own advice? What if it could take actions rather than always wait for me? So this king is never satisfied, even though he was able to get his wise men to sort of invent something that is seeing what is going on the battlefield. It almost seems like he wants this same machine to help him fight or perform some actions. So he just wanted to be lazy. And so the wise men reacted that this king is never satisfied. First, he wants wisdom. Now he wants sight and limbs. So from thought to action, so the new creation that the wise men created came with some enhanced features. It could send messages, it could deploy troops, it could trigger defenses, manage supplies, and act with the king's permission. So this machine could do stuff for the king, but it still needed some sort of permissions from the king. So in the end, the complete transformation for the machine was that the machine could observe, strategize, and also act. And in the end, the kingdom expanded, and there was growth and everything. Let me just skip. Okay, yes, I can't skip this part because this is the reason why we are here. Sorry. So let me go back. Yes. So now that the machine could act, basically, and the reason why the machine could act was because the wise men built in new features into it so that it could act. So the actions that it could perform in their world was that, sorry, let me go back. So the new features that this machine had was that it could gather knowledge from different sources on its own, from the stone tables, from these are magical kind of, what's it called? Folktale kind of stuffs that you have here, maybe in an utopian world. And the machine required that this sort of extensions be added to it. So, but as these extensions were added to it, the complexity became too much for these wise men because they were the one building all these extensions to help that machine to basically fight the wars. And so the wise men had to stop, and they thought again that if we keep on building this sort of extensions for this king, it will get to a point where we won't be able to manage these extensions on our own. So that was where the crisis came from. What they had to now do is that, okay, instead of us building these extensions for this machine, let us meet the sources of these extensions and ask the owners of those sources, which is something like the blacksmiths, the harbor master, the royal treasurer, and all other people that provided extensions for that machine. Let's ask them to use a common language to talk to this machine so that instead of us building all the extensions for the king or for the machine, these providers will be the ones building those sort of extensions. And then, and that was what happened. They shifted the load from them building these extensions for that machine. They shifted it from themselves, that's the wise men, to the providers of those extensions, basically. Okay. Okay, so let me now give you the translation of the story that I just told. The king here are the AI users, the common users that are always demanding that, okay, we need something, an intelligent machine that could help us perform some task. The wise men are the AI engineers and researchers. The vault is the data that the AI, as we know today, was trained on. The war machine are the large language models, for example, that we have, basically. So you could look at it as this war we are fighting is like a knowledge war. We are trying to battle or fight against the lack of knowledge, basically. And so we noticed that after some time, when all the large language providers released their large language models, it could not connect with the internet, for example. Now, most of those large language models have a way of connecting to the internet. That is the all-seeing eyes that I explained in the story, where it's able to see the battlefield and give contextual information to the models. The clock hands are tools that could perform actions. So currently, we have some sort of CLI tools like copilots that could sit on your code and write your code for you while you just sit down and relax. Basically, it learns from your existing code and is able to, look at the context and maybe fix bugs for you. And all you just need to do is to accept every change that it makes, basically. So that's the clock hands that can perform actions. RAG, which is a mixture of the knowledge from ancient and fresh knowledge. So RAG is a part of large language models that allows you to bring data from outside, which is data that the large language model was not trained on. It could be data from the internet. It could be data from different other data sources. So it's just a component of large language models. So it's the all-seeing, it's part of the all-seeing eyes. Then the common tongue is where MCP comes in. The developers of the large language models, OpenAI, Anthropic, and Google, all the large language models, have made some of their large language models to be able to communicate with services like, they have integrations with services like Slack and some other database providers. You could use your large language models to talk to Excel. But the problem is, if they keep on doing that, they'll have a whole bunch of integrations to manage. So what they did was to sort of shift the load from them managing these integrations to the providers of this service. So, which is what I'm talking about. Countless custom bridge would cause, integration complexity. And the wise men, which are the developers, will become the bottleneck, and you won't be able to get integrations out as fast as possible from these suppliers. Different diverse data source. So if you task maybe developers at OpenAI to provide you an extension for Microsoft SQL, they also need to do something for MongoDB, MySQL, and the others. So instead of them doing it, they've shifted the load to other developers. I'll just skip this part. And yes, that's the end of the slide. So I hope we're able to kind of understand it better with these stories, because the MCP is just a protocol for you to allow the large language models to basically read from data sources and also sort of perform actions using tools for you. And yeah, that's it. Thank you very much.
Thank you very much. So, any question from anybody?
So I've seen a number of times where sometimes the action that you ask the MCP to do, it hallucinates and just does something by itself, or does like too much or too little.
Mm-hmm.
Are there things that you've had to put in to kind of force it? Have you had to put anything in to force it to behave how you want it to, as opposed to it just,
I think you experienced.
I have the cool answer, or the simple answer and the tough answer. The simple answer is sometimes the hard done. When you're not a pro paying user. So if you are paying for the tool, it's typically much smarter than when you use the free tier. So behind the scenes, so that's the short answer. Sometimes it deliberately asks them, but the more robust answer there is, for example, if you are talking about a topic, for example, you are generating Excel sheet, right, and then you switch to a different topic, then it might not immediately switch the provider, the model that is presenting to you. So different models have their specialization where they've been trained. So, but you're trying to have general question, you switch from space to coding, to improve this, to create an image. So when you try to perform this action, it switch every time. But sometimes those switching is not efficient. So, and when you throw in a context that is not properly trained while the model is active, then it fumbles and it gives you the wrong output. Do you want to speak on that?
Yeah, so I think, your MCP has tools that you want the large language model to use, basically. And you may not necessarily type it as a function, but you have to be as descriptive as possible for it to know that, okay, this is where you are not necessarily typing code, but you have to kind of understand the engineering, like prompt engineering, how to effectively prompt it, to look at that data source. And if you look at the demo, you see that for the cloud client, it showed us a window where it's created the JSON what's it called, payload that it sent to the MCP. So for that, you'll be able to know that, okay, yes, this is talking to my MCP client. But I don't know, I've not used any other client to sort of connect to see how.
One other thing that can help you get great output from the AI interface is when you tell it to assume a role. So, for example, when it says, for example, you're talking about nature and flowers, and now you want to talk about physics, then when you tell it, okay, assume the role of a physics professor, then tell me about the theory of relativity or why this, then that helps it to switch to the burst model that can give you the right response.
Okay.
I have some more questions on that. No one else is. Yeah, okay. So one of the other things is I've seen malformed JSON be created by the LLM. So you say to the LLM, create a story on the story generator.
Yeah.
And it comes up with some JSON payload that either the parameter names are wrong, the keys are wrong, or sometimes it just doesn't create valid JSON. If you're, do you have to have some extra stuff on the client side that deals with retrying that, or do you have to, because you're sending it into another LLM?
Yeah.
Can the other LLM just take the malformed JSON and just treat it as if it's properly formed in the first place?
Yes. So what I would just say is basically you are trying to talk to a tool, for example, an API that is depending on structured data, but you are lazy to write that integration on your own. MCP is helping you to change your natural language to something that API can consume. So I would say if we know large language models to always hallucinate, then that is not a problem with the MCP aspect. Is a problem with how the large language model is, sort of interpreting that data, basically. So if, for example, you have a paid version that has like more power in it, I don't know what's power. I don't have the word for what's more, but you understand what more power would mean. Yes, well, maybe it's trained on more data, and yeah. maybe it will be able to do better in avoiding those issues. But we just know that basically most of those large language models are not where we want them to be yet. So definitely you have some of those times when it hallucinates. I'm still studying what's it called? The different uses of MCP, because I feel like using it for some kind of integration, you could have some security issues or some ethical issues with just throwing everything at it, basically. So it just shows that we still have to be careful with using it, basically.
Yeah,
Yeah.
to add to that, I can imagine a scenario where you have some poor data in your database. Then you want the MCP to fetch that data, take it to the LMM, then make it on hold. And it might result, it can be garbage in, garbage out again. I think from my experience with it, sometimes I am just very detailed about what to do. For example, by telling it to be critical about it, leave no stone untouched. I've used that word a lot. Leave no stone untouched. So by giving it assertions to be very deliberate about how it's going to deal with the data, then I see better responses in how it treats it. It's like a child, or the way it works. It gives emphasis on your input. So when you don't provide such emphasis on data accuracy or data quality, it might just give you anything it likes sometimes. But when you emphasize, okay, this must be correct, I'm sending in 50 rows, then I need 50 rows back out, then those things, then you can get stronger or better answers sometimes. But it's still a shy, and of course, different companies are boasting of their capacity of their AIs daily, and I think in the next 5 years, it's going to be astronomical.
I don't have a question, but I do have a thought directly related to your question. It's not an MCP related thing, but I've done lots of LLMs within broader automation where I've absolutely been dependent on a fixed JSON structure, and I found some 3 good ways of improving that. One of them being clear in my markup of my prompts, being explicit that this is a section related to the output format. Expressly having a constraint or a thing that mentions I want my response in JSON format in the ChatGPT docs. It said include this if this is the response type that you want. Sometimes if you confuse it with backticks or some other markup, it will then reinterpret the JSON as a string, which is what you don't want. So those two, and then just spelling it out in really clear terms with some comments, I found even for stuff I want fixed every single time across a variety of model sizes, I get
Please, I forgot. That to be basing most of the listing on instructions. Yeah, I forgot. Yeah. Most of them. I think it's like Copilot config. Yeah. Okay. Thank you very much. Yes.
So the last part of that question is there's this configuration file specifically for Copilot where you can structure your prompt in a syntax like a README syntax. Well, I'm trying to recall the name of the file. GitHub.
The instructions.
Yeah,
yes, the instructions file.
Yeah.
So
most of them, like all of GitHub, Lord, they all have instructions.
Yes.
Instructions MD.
Yes, instruction MD. So if you can understand the syntax and then you set your constraint, there's a guide. They have standard template where you can guide. Okay, you must do this. So if you can do that, then you send the input. It's going to do exactly how it's told. That's the last answer to that from what I can think of. Thank you. Anybody else? All right, Kevin. Thank you very much.
For having me.